Good morning, I am Bhaskar Das. Today we will be discussing something about the human eye. So in earlier classes we already know about what is reflection and refraction. In those topics we have anchored some of the examples. So now a real life example of where refraction occurs is our human eye, which is known as the most beautiful organ in our whole body part. Okay, so today we will see using a model of a human eye. So this is, you can see as the cross section of the human eye, how that human eye looks like if you cut it and see it as a cross section. Okay, so now you can see this is the whole human eye in a cross section. So this part, the outermost layer, as you can see, the blue colored layer is known as the sclerotic. What a sclerotic does? A sclerotic gives the eye its shape, just like an egg cell have given its shape to the egg. Similarly, this sclerotic, which is made up of some fibrous tissues, gives the eye its shape. Next, you can see as the green line, it's the sclerotic. What the sclerotic does, it's another thin layer of tissue which is darkened in color. Why it's darkened in color? Because if there is any other color, as you all know, that our eye is only sensitive to white light. So white light has many components. So if any component is being reflected through this part and enters the retina, then it will be interfering with our focus, and as a result it will be interfering with the image that is formed in our brain. So that's why the sclerotic part is darkened, such that there will be not be any internal reflection. Okay, so next, the yellow part is the retina. So what a retina does, a retina focuses the image on itself and take the image in the form of electrical signals to the brain through optic nerve. So retina here is connected to the optic nerve. This is the optic nerve which goes to our brain. So here you can see these nerves, red and blue nerves. These are the nerves, and this acts as a retina. You can see there are many nerves inside this part. So this all acts as a canopy. This spreads like a canopy, which is known as the retina. So this part is okay. Then you can see the green part is connect with this thin rod-like structures. As you can see, these rod-like structures, these are known as ciliary muscle. It is connected with the lens. The lens, this is the white part, the white portion is the lens. This lens is made up of jelly-like substance such that it can elongate and contract using the ciliary muscle and help us in focusing far distant objects and near ones. Okay. So now this blue part, as you can see, this part and this part is the iris. So what an iris does? An iris allows the how much amount of light we want to allow in our eyes, so that we does not have enough so that we can be blind. Okay, if a lots of light enters into our eyes, we can be blind. So that's why the iris controls the amount of light that is entering into the lens towards the retina. Okay, so now as you can see, this part is cut out. Okay, this is the pupil, it's a slit. Okay, the pupil is controlled by, the size of the pupil is controlled by the iris. Okay, so as you can see, every individual have the color of the eye. No, it's say brown, blue, green, or you can say golden. Some of them are golden. Yes. So this color depends upon the color of the iris. Okay, and this part is known as the cornea. You can see the outermost layer is the cornea. This is known as the window of the eye. So what a window does, a window allows the amount of light, allows some light to come into our room. Similarly, this cornea part also does the same thing. It allows the light to come enter the eyes. So here, as you can see, this white portion inside the cornea, it's filled with a jelly-like substance known as aqueous humor. Okay, so what this aqueous humor does, it helps our eyes in coping with any pressure difference between the eyes and the outside environment. For example, if you live in a low-lying area, as we live now, we are living in a low-lying area. But if you move to a higher areas, for example, a hill station, a mountain, then the pressure difference, there will be pressure difference, no? So because of the pressure difference, your eye can be damaged. Okay, so this aqueous humor helps in preventing the damage because of the pressure. And also sometimes when you blink, your eyes get washed up. Why? Because when you blink, some fluid from the aqueous humor come outside the cornea and it clears your eyes. Okay, then it's the here this final part, this whole area is filled with another gel like substance known as vitreous humor. The function of all this part is same, just as the aqueous humor, it also prevents any damage from pressure. Okay, so as you know, we all have completed all the structure, how it works. So now let me tell you how this diffraction works inside the lens. Okay, inside our lens, eye of the lens. So here, when light enters upon the pupil from this part, as you know, this cutout is the pupil. It enters this lens like this. You can see like this. It enters into the lens, and then it refracts. As you know that inside it is a double convex lens. A double convex lens, what it does, it converges the light that is coming inside the pupil and make the focus on this retina, this part. Okay, this part. And you know, this retina is covered with rod and cone like structures. Okay, the rods are sensitive to black and white lights. It's not black, you know, black means no light. It's really sensitive to the white light. And the cones, they are sensitive to any other lights other than white and black. For example, yellow, mostly red, blue and green. Okay, RBG, as you can say, red, blue and green. So this together gives us the sensation of light and different colors that is occurring inside the retina. So by this, now we know how our eyes works. So like ours, in our world, there are many animals who have same eyes like us, and their structures are almost like this only. Okay, so this is the functioning of a human eye with all its structures. Okay, thank you.